Oh, hi there. Let's find the value of the following series, shall we? Okay, so first thing we have to do is it arithmetic or geometric? This one is quite clear to me that it's arithmetic because I can see that minus 3.5 grew to minus 2.5, and we added 1.2 there. And then we add another 1.2, and we get to that. Okay, so I know that my first term, is negative 3.5. And then my common difference is plus 1.2. And the number of terms is, I don't know how many. So let's find out how many terms I would need to get a term 20.5 as my final term. All right. So we're going to first go T of n is equal to A plus n minus 1 times D. All right, let's sub in. So Tn equals 20.5 equals a negative 3.5 plus some number n minus 1 times 1.2. Okay. Solve this for n, this, okay? And that will tell you which number of term that last term was, okay? Because this is the last term. So if the last term was that, well, that must be some n that makes it. So let's find it. Okay, add 3.5 to both sides, and you got 24 equals some number minus 1 times 1.2. Divide both sides by 1.2 gives you, what is that, 12? No, 10, 20, 20, 20, 20, 20. 20 is equal to n minus 1, and n is equal to 21. And when you notice stuff like that, that's a Fibonacci number, you know that that's maybe the correct answer because I like them. Okay, so did you see how I did that? So here I divided by 1.2, both sides. 24 divided by 1.2 is 20. And then you add 1 to both sides to get n as 21. So now we know n equals 21. So we're good. We can get started. All right, so how do we do that? Well, let's go. The sum of an arithmetic series is given by the number of terms divided by 2 multiplied by 2 times the first term plus n minus 1 times the common difference, and that's your formula. Now substitute in with these numbers. All right, so the sum of this 21 term sequence makes the series 21 divided by 2 multiplied by 2 times negative 3.5 is, I'm just going to write down negative 7 if you don't mind. That's 2 times the first term plus n minus 1. Well, I'm just going to write down 20. Okay, you can start cutting some corners, all right, if you can see that you can cut corners times 1.2. Okay. Now this simplifies in here to negative 7 plus 24. Negative 7 plus 24 is 17. So the sum of the first 21 terms is equal to 21 over 2 times 17. And that is 357 over 2. Okay. Now let's try it from here, calculator method, see if we get the same thing. Calculator method is, I'm not really sure, but I'm just going to do it. 7, but it's negative, plus 20 times 1.2, and the bracket equals 178.5. Let's just multiply that by 2, and there it is, 357. 357 divided by 2 was the answer we got on the calculator, so that is correct. All right, next, this one. What happens? 0.01 plus 0.04 would give me that. But then 0.05 plus 0.04, which should give me 0.09. And it didn't. It gave me 0.25. So it's not arithmetic. There's no common difference. Common difference didn't work. But I noticed that if I multiply by 5, and then I multiply by 5, and blah, 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 I get the next term of the sequence. So My A is equal to 0.01. My R, my common ratio, is 5, and my N number of terms is I don't know what yet. I need to figure out what number that one is, which number term that is. So let's find it. Okay, so 3906. So I know that Tn is equal to A R to the n minus 1 for a geometric series. And in this case, Tn is equal to 3906.25, which is equal to A, the first term, 0.01, multiplied by 5 raised to the power n minus 1. Okay? And now simplify this as much as you can. Divide both sides by 0.01. Okay? And you will find that that's just the number 390625 equals 5 to the sum power n minus 1. And so now we can use change of base. And if you don't have your powers of 5 memorized up into the 300,000s, then you can do this. Because I also don't happen to remember it either. 5 times 5, that's to the power 2. Count them on your hands. 2, 3, 4, 5, 6, 7, 8. There's that number. 5 to the 8 equals 5 to the n minus 1. 8 equals n minus 1. N equals 9. Okay, cool. So now you've got everything you need. Equals not a question anymore. Now it's a known thing. There's 9 terms. I've actually shown you 4 of the 9 terms already. But you don't need to see the other ones because you're just going to go ahead and say that the sum of the first n terms of a geometric series is the first term multiplied by 1 minus r to the n, all divided by 1 minus r. And then you're going to go ahead and sub in. You're going to sub in 0.01 multiplied by 1 minus 5 to the 9, all divided by 1 minus 5 will give us our answer. I'm not doing that in my head, but I already have 5 to the 9 on my calculator. So let's just make that negative. We're going to add 1. So that's the number inside the bracket there. Multiply by 0.01 equals that. And then divide by negative 4. Oh, divide by 4, but it's negative. Equals. There. Is that it? Is that right? I feel like I made a calculator error here. My goodness. Yeah, it should not be that. Okay, let's find my calculator error. Clear? All right, let's just start it again. 0.01 times, put it in brackets, 1 minus 5 raised to the power 9, end the bracket, equals, all divided by 4, but it's negative. That looks much better, doesn't it? Okay, cool. So 4,882.81. Ooh. People who think 8 are lucky would like this number. Okay, 4, but they wouldn't like it because 4 is unlucky. All right, 4882.81. There. I circle it. That's the final answer. I believe that's correct. All right. So that's how you figure out these sums of sequences without a lot of information, just seeing the first few terms and the last term. All right, everyone. Bye for now. Any questions, hit me up by email. And my off button is in here somewhere. Okay, bye.